Good morning, guys. Hopefully you can all see my screen. If you've got any issues, please just let me know. But I am Rebecca James. So I am the ITS Business Development Executive for Navtech Radar. And I'm joined this morning by Kieran Marsh, who's our Technical Project Manager. So a key area of my role is working closely with partners, road authorities and concession owners to understand the issues and priorities that they're facing and how technology can be implemented to overcome these challenges. Kieran leads our ITS project delivery team. He's got a wealth of knowledge and experience in delivering this technology across the world. So this morning, I'm going to be discussing why radar technology is being implemented in the ITS environments, the safety, efficiency, and environmental benefits of the technology, and how it can provide multiple capabilities from a single sensor. We'll then cover some case studies of real-world deployments and the results that we're achieving, and then we will have time for a Q&A session at the end as well. So I thought it was important to introduce you to Navtech Radar and highlight why we're best placed to be delivering these successful ITS projects. So we've been implementing radar installations since 1999. And we actually started in the industrial automation sector. So we delivered the world's first fully automated port in Australia. So we've got three core applications at Navtech Radar. So ITS, which I'll obviously be discussing today, as well as continuing our work in the industrial automation sector, and then also security. So we provide wide area surveillance and perimeter protection. So across these sectors, we have nearly 5,000 radar sensors installed in over 20 countries. And our focus is on continually improving and developing the technology. And over 70% of our employees are engineers. So every element of the radar, from hardware, software development, through to production, project delivery, and then finally customer support, is all still done in-house at our headquarters, giving us the ability to fully manage a project from start to finish, while also smoothly embedding any customer feedback we receive into our product roadmap. So why are road authorities looking at implementing new technologies? So as the number of road users continues to grow, risk levels remain high, and the European Commission found road fatalities in 2022 actually increased by 3% compared to 2021. So to help improve the safety, of real importance is the ability to understand everything that's happening on the road. So past implemented technologies gave us a snapshot of what was happening on sections or areas of the road, but we're able to gain a full picture of the roadway. So how are we able to gain this view? So this is our 360-degree rotating radar, the CTS 350X. I appreciate it looks pretty unassuming installed on the side of a Perth freeway in this image, but this unit rotates 4 times per second, so collecting over 1.4 million points of data per rotation, which creates an extremely high resolution image of the road. It's designed and manufactured to withstand extreme temperatures, dust, debris, water, and it has a compact design for easy shipping, handling, and installation. And as you can see from this image here, has been mounted to existing infrastructure to ensure project costs are kept to a minimum. I'm sure the next question will be, so how does it work? So what does this unit actually do? So radar systems work by measuring the time of flight from when a transmitted signal leaves the radar, hits a reflecting target, and returns back to the radar. So this image here is still from a toll road installation that we have in the United States. So the purple circle is your field of view from a single sensor, which really highlights the range that we can get. We then narrow down the coverage by manually configuring the carriageway within our Clearway software. So the green that you can see on the left-hand side is the raw radar data. So completely unprocessed, straight from the radar, but you can see is covering across multiple lanes. So in this exact instance, it's 4 open motorway lanes and 2 express tolling lanes in both directions. So a total of 12 lanes. And then on the right-hand side, you'll see this is once we've processed the raw radar data through our Clearway software, and you can see we're tracking vehicles and their direction of travel. So the Clearway software is completely configurable. The alarms are rules-based and can be set up in particular lanes or zones. There could be multiple alarms and multiple zones activated, and the blue sections that you can see are where we've specifically set up count and classification zones. So on this specific project, dynamic toll pricing was used, meaning the cost of using the express toll lanes fluctuated depending on the volume of traffic across the open motorway lanes. So when you're amending your express lane pricing due to peak times, it's essential that the data driving these price changes is as accurate as possible. This is just an example of one of our applications. So having a rich set of actionable data plus configurable software allows us to offer multiple applications, and I'll cover these shortly in the radar capabilities. So with 360-degree rotating radar, as you can see, you have up to 500-meter radius detection of the entire roadway with one sensor, giving coverage in both directions and covering as many lanes as required. And rotating 4 times each second with high resolution and accuracy, the radar's detecting, identifying, and tracking each object. So this gives you data not just when an accident has occurred, but potentially collision-causing objects such as debris in the road can be detected and dealt with. And radar also works in the harshest of conditions when an incident is most likely to occur. So heavy rain, snow, bright light, complete darkness, and even smoke. So due to its high range resolution and accuracy, the Navtech radar sensor produces an extremely rich set of data. So being able to see your entire roadway with a data-rich image allows us to offer more than just incident detection. So we can provide an abundance of capabilities using the same sensor. So this includes wrong-way driver detection, so detecting and tracking movements of drivers going against traffic and allowing operators to take action by closing lanes and contacting the appropriate authorities. Detection for safety, such as pedestrian detection and debris detection, as I mentioned, on the roadway. We offer emergency situational awareness to allow easy sharing of key incident data directly with emergency responders. So this is particularly for challenging conditions such as tunnel fires. For traffic management, we provide count and classification to analyze real-time road use and queue detection. So if the traffic volume reaches a pre-configured level and the average speed falls below a minimum speed threshold, Clearway can raise an alarm to the operators. So being able to offer the number of capabilities as we can minimizes the need for several different technologies roadside, reducing the overall cost of the project and the infrastructure required for that. So where are these sensors deployed and how are we seeing efficiency and safety benefits from the technology? So a road operator is primarily measured against how well are my roads running? Are they serving the community members that are using them? So data from research analytics firm INRIX revealed congestion caused by the worst traffic hotspots could cost drivers in Europe £183 billion by 2025 due to the time wasted sitting in gridlock. However, the evidence is clear. Simply building more roads is just not a viable option. So we are installed on the Kwinana Freeway in Perth, Australia. So this is a 13-kilometre stretch of road that was Australia's first smart freeway. So Main Roads Western Australia wanted to use technology to maximise their existing road capacity. So we were installed primarily for our automatic incident detection capabilities. So the core reasoning for them to create a smart freeway was to improve traffic flow on the road by detecting crashes and breakdowns, helping emergency crews to clear the road quickly and get that traffic moving again. So safety and efficiency of the freeway was paramount. So the smart freeway has reduced the journey time of commuters by 10 minutes per journey per day. I appreciate that may not seem a very large number until you realize if you commuted every day, that's an additional 3 days a year that you get to spend at home and not on a motorway. And that's per individual per day. So the scheme's been viewed as a great success by the end customer and as well the general public. And we're actually in the commissioning phase of their second smart freeway project. As I mentioned earlier, radar technology performs in the harshest of conditions. So Sweden gets extreme weather during the winter months, and this posed a real issue for the road authority there. So on the E4 motorway, the difficult driving conditions experienced by drivers such as rain, snow, fog were leading to higher than expected numbers of slow or stopped vehicles, and in turn, a greater number of vehicle collisions. So the authorities were relying on operators to spot incidents on CCTV or wait for an incident to be reported by phone. This was just not effective to detect all incidents quickly, and the operators were not being provided with enough information and crucially enough time to deal with situations before they escalated, for example, a secondary collision. So many different technologies were considered for the project, but knowing that video-based technologies were hindered by the adverse weather, Navtech Radar were awarded the project. We were installed to automatically detect slow or stopped vehicles, pedestrians, and debris. And integration was an important element of this project, and our Clearway software was integrated with their existing SCADA system. And the system also integrated with the existing video cameras to automatically direct the nearest camera to provide a view of the incident. So the Ryfast tunnel in Norway is actually Navtech Radar's single largest installation to date. So we have 102 radars covering just under 30 kilometers. And the key requirement was to increase safety in the world's longest subsea road tunnel. So our Clearway ITS system is providing a number of capabilities from the sensors, including automatic incident detection, stopped vehicle detection, pedestrian detection, and wrong-way driver detection. We've also integrated with the installed cameras so that when an alarm is raised, the cameras are automatically directed to record the incident for 30 seconds. So this means with no intervention or additional work, the operators in the control room can instantly see what's happening. Wrong-way driving can cause catastrophic incidents, as we know, especially within a tunnel environment. And so our wrong-way driving alert will also automatically close the tunnel. So this prevents additional traffic entering and being involved in a high-speed collision. Tunnel environments also have additional safety concerns. So as well as detecting incidents, our Navtech Radar Clearway system gives emergency teams full situational awareness when responding to an event within the tunnel, such as a fire. So the tunnel can take up to 20 minutes to drive through, and we provided our situational awareness feature. So we're able to provide operators with a visual map of the area with all movements appearing on the map for visual information to coordinate that emergency response. So we work with a very talented and experienced team to deploy and commission these systems that I've spoken about. So I'm going to hand across to Kieran, who will talk you through the stages of delivering another large road infrastructure project, which is Transmission Gully in New Zealand.
Thanks, Becky. So just to give everybody a quick context overview of the Transmission Gully project, this was a new road connecting the northern suburbs of Wellington on the North Island of New Zealand, the nation's capital. This was built to bypass an existing coast road that suffered from multiple closures over the years due to landslips. So this project had very high visibility in the country. The project requirements were for automatic incident detection along the 28-kilometre stretch, plus all the connecting ramps, which numbered 17 in total. Additional requirements were for count and classification at major points along the highway and to monitor the ramp performance for KPI reporting back to the Transport Authority. Commissioning of the radar system was interwoven with the building of the road, which provided its own challenges. We worked well alongside other contractors, including network architects, builders, and other software development teams, and it was a huge collaboration between many aspects of the road construction. At Navtech, we have a well-established commissioning process that is flexible enough to fit into most project schedules, as was demonstrated on Transmission Gully. This can be applied on site using our own highly experienced engineers, But equally, as we did on Transmission Gully, we can train partners to undertake all of the on-site work on our behalf. Given Transmission Gully was commissioned during the COVID period, we were able to partner with a highly experienced ITS engineering team to work with installing and commissioning the radar system. So just to give you a quick overview of our delivery process, so that the first step is usually design, and this is quite often undertaken at the pre-delivery stage. And this allows us to give an accurate estimate of the number of sensors required according to the specifications of the project and the road design. All new road and retrofit projects, so retrofit I mean by installing on existing roads, come with certain design constraints, and we work with project engineers to ensure that our system fits within the project constraints. We've got many years of experience of designing radar systems, and working alongside Navtech during the design phase is one of the most critical activities to ensure the optimal performance of the system, not only at delivery, but remembering that this is going to be installed for a 10+ year lifetime of the system. Many things must be considered, including but not limited to bends in the road, changes in elevation, locations of flyovers and bridges. So once we have a design, then we move on to the survey stage. On-site survey confirms the design will work within the road environment. The radar is a line of sight instrument, we mustn't forget that, and many things such as signs and bridges and gantries and barriers can cause obstructions that prevent effective detection in the road space. All efforts are made at the design stage to mitigate these issues, but an on-site survey provides a final confirmation that the design is de-risked as possible by ensuring performance will not be hindered by any roadside infrastructure. Survey might also highlight required changes in the design that weren't possible to predict from the plans alone. So it's a very critical part of the commissioning process. Once the design has been finalized, we move on to the hardware build. All radars are built by hand at Navtech Radar in our dedicated manufacturing facility here in the UK. Each radar goes through a series of stringent tests to ensure it's ready to go out on the roadside and remain operational for 10+ years. If physical servers are required, we will build these as well to the required specification before shipping. And we also undertake factory acceptance testing to ensure that all the supplied radars and servers are configured correctly and working and communicating as expected. Once the hardware has been built and shipped and delivered and received by the customer on site, it's then moving on to installation. At this point, power and network and mounting brackets should be ready by the roadside, and our radars are installed on the roadside in the design locations, and communication is confirmed back to the server. Then we move on quickly on to the commissioning, and this is the final stage of the roadside work. Here, radar is correctly leveled to the road, ensuring optimal detection upstream and downstream of the radar, remembering that our radar is a 360-degree device looking in all directions. This is where we also undertake the first tests of functionality by performing tests on the road at this stage. So on Transmission Gully, installation and commissioning were carried out by a local partner because of the COVID travel restrictions. Navtech engineers were still able to connect to the software remotely and directly guide and assist the remote engineers, the on-site engineers during the radar commissioning activities. The radar sensors are the most visible element of our system, but the software is the lesser obvious, but equally, if not more powerful element of the entire system. The Clearway software is able to control all aspects of the radar system and how the signals from the radar are processed. Software setup is usually done remotely, and this was no different on Transmission Gully. Once vetted, Navtech engineers were given access to the Transmission Gully network to configure the system appropriately. Once the hardware and software have been commissioned, the system is ready for testing and to demonstrate the required capabilities to the customer. This usually consists of recreating some or all of the on-road events in a test environment to demonstrate detection of the radar and the correct passing of signals through to the Clearway software and all the way through to the traffic management software. On Transmission Gully, this took several months as testing followed the construction of segments of the road. This required the presence of all stakeholders to witness the successful completion of each segment of tests. These tests provided assurance to the customer that the detection of the system is functioning as required to the customer's specifications. The next stage is optimization, which requires live traffic to be flowing. Up to this point, everything has been done in a neutral or test environment. Having live traffic allows Navtech engineers to observe and respond to how the system behaves in all traffic scenarios. On Transmission Gully, this required a period of tuning and adjustment to ensure that the operators were comfortable with the radar system. Once travel restrictions had been lifted, we were also able to send an engineer to spend time with the operators to explain to them how the system worked and how our alerts related to what they were seeing on the road. This has proven to be an extremely useful exercise, not just on Transmission Gully, but on other projects too. The radar system requires some considered work when installing the system and is a critical area of expertise we provide alongside the provision of the device. This is done to ensure that no revisits to radar sites are required, which may impact road usage. So I'll hand you back to Becky, who'll continue this topic to talk about how low impact our installation process is.
Perfect, thank you, Kieran. So the safety and the efficiency benefits of the radar are clear, but what environmental benefits can be experienced with this technology? So as you can see on the left, we know that queuing traffic brings increased environmental issues and that constant acceleration and braking is the primary culprit. So we look to tackle this in two ways. So we've recently removed all serviceable components of our radar. So our new motor was developed in-house by Navtech engineers and drives the rotating part. So that makes it service-free for its 10-year design life. The radar sensor also requires no cleaning or additional maintenance. So this means less site visits, less shipping, and less congestion caused by lane closures to complete that removal and reinstallation of the sensor. It also means that once installed, there are no roadside works at all. So lowering the life cycle cost of the system whilst maintaining the same level of performance and reducing the environmental impact. And with radar technology, road authorities and concession owners can take a more proactive approach to traffic management. So understanding everything that's happening on the roadway to make those decisions to increase efficiency. So as we saw with Kwinana, and reduce the queuing traffic. They can also react quickly to an incident when it does occur, so clearing the road as quickly as possible and returning the traffic to its original flow levels. So safety is at the centre of everything we do at Navtech Radar, and we're really excited about how 360-degree rotating radar is improving the ITS environment and its place in the road management ecosystem. So the solution is already trusted as a key technology to create some of the world's safest roads and tunnels around the world, as